Hello everyone, my name is Sanjay. I am working here as an assistant professor in the Department of Mechanical Engineering. Today we are going to see the experiment Sine bar and Sine center. Sine bar and Sine center does not vary much except this stand. This is Sine center where at both the ends are fixed, and we remove this part, it becomes Sine bar. Today we shall see Sine center. With this experiment we use the Sine bar tool with a fixed stand here along with dial indicator. The dial indicator consists of plunger, dial gauge and a L stand. Here the conical shape what we are seeing here, this part is the specimen. Here this conical shape is a tapered part where we measure the taperness of this part and we find out the angle of the tapered line. Okay, to use this we initially use the dial indicator where we touch the dial indicator on the conical part which is called a specimen, and then I slowly move it towards the end. I slowly move it towards the end and take the measurement. Now we can see the dial indicator has moved back to 0. The dial indicator has moved back to 0 and it is coming towards negative. Now we can see it is coming towards negative value. So to make this positive, what I do, I'll take this slip gauge. We all know what a slip gauge is. I take this slip gauge and I build it at the base of the Sine center. Now I build it at the base of the Sine center here. I build it here so that the taperness is parallel and it is minimized to 0. Now once I build it here, I bring back it, I check it in the dial indicator to measure the value to 0. Now once 0 is achieved, I take the length of the conical shape, that is the specimen, and then using the formula alpha is equal to sine inverse of h by L, I find out the value of alpha. Similarly, the same thing I will be finding out theta value using the values capital D minus small d divided by 2L, where capital D is the biggest diameter, that is at the center of the specimen where the diameter will be more here, and small d will be the least diameter, that is the diameter of the least part of the specimen. Capital D minus small d divided by 2L, where L is the overall length of the specimen. So theta is equal to capital D minus small d by 2L and alpha is equal to sine inverse of capital H by L. Capital H is nothing but the height of the slip gauge is what I have built here, and L is the overall length. Using these two formulas we find out alpha and theta. This explains the experiment Sine center and Sine bar. The common viva questions that can be asked is, what is dial indicator? Dial indicator comes under which comparator? What is Sine center? What is Sine bar? What are the differences between Sine bar and Sine center? What is a slip gauge? What are the slip gauges are made up of? The tools used for production of slip gauges. Thank you.